Okay, so let's give you guys some more practice. So given this here, given this table here, work out dy by dx of this. Okay, so here work out dy by dx here. Um, if you get a graph plotter and plot y equals this thing here, it will give you this red line here. It will give you this weird zigzag line here. And there is a reason why it's a zigzag line. You just got to sit down and really think about it for yourself. So here visualize this thing as being there is a reason why it's a zigzag line, but I'm not going to explain it to you. But you just got to sit down and think about it for yourself. So here, think of it as being one machine here. So you've got a machine here, sine of x here, and then you've got another machine here, the inverse of that machine here. So here, if you put a number, let's say a, into this machine here, it will spit out whatever over here, and then if you put that same whatever into here, it will spit out blah blah here. But if you really do have to sit down and think about why it gives rise to this zigzag line, but there is a reason for it. You just got to think about it for yourself, okay? But the important thing here is that when you look at this thing here, because you've got inverse sine here. Now looking at this thing here, because you've got that inverse sine here, look at this. If you have inverse sine of whatever here, you see the inverse sine of whatever only makes sense if the whatever is within -1 and 1. The domain for this thing here, the domain here is between -1 and 1. So this thing here only makes sense if you are restricted within this this -1 and 1. So the whatever here has to be in between -1 and 1. So when you look at this here, you see this whatever here has to be in between -1 has to be in between -1 and 1. So this whatever here has to be in between -1 and 1 here. So yeah, so now inverse sine to both sides here. So inverse sine minus 1 here, and then you see, hang on, inverse sine on this side as well, inverse sine -1 here. You see, if you look at x here, if you get your calculator and work this inverse sine of 1, well, whatever the inverse sine of 1 is going to be this point here. It's going to be this point here. So the point here is that, hang on, this is also negative. This here is this point here is negative. Sorry, inverse sine of -1 here. So the point here is that this here is only valid when x is in this region here. So beyond that, it doesn't really make sense. Beyond that, it's really beyond our control. We don't know what happens beyond that. So when you're given this here, because you've got an inverse sine here, it only makes sense if it's within this region here. If it's within this region here. Okay, so beyond this, we've got to discard everything beyond this. So we can only look at this in this region here, because given this here, you can imagine it as being like this. You've got a machine here, sine of x here, and then you've got another machine here, inverse sine of x here. If you put, remember this thing here. If you have this here, f of x, and then you put the f of x into the inverse, then it should give you back x. My point is that if you put, let's say, a into here, and then you get the whatever, and then you put the whatever into here, you should get back to a. You should get back to a, because whenever you put a function in the inverse, you should get back to x here. But then if you look at this here, if you put 2 into here, then if you put 2 into here, then it should give us back 2, but it doesn't in this case. It gives us back something else here. So here already it breaks down. My point is that you've got to discard everything beyond this, then it will make sense. If you discard everything else there, now if you put 1 into the function, it will give you 1. If you put 0.5 into there, it will give you 0.5. If you put negative 0.5, it will give. My point is that because you've got this inverse thing here, you've got to take the domain into account. If you don't take the domain into account, it really is beyond your control. It will give you something that you don't really understand. So remember to take the domain into account. If you take the domain into account, now it makes sense here. This straight line here is a function. It makes sense. Okay. Well, anyway, find dy by dx of this here. Okay. So press pause and have a go. Okay. So to do this here, hang on. So given y equals this thing here, differentiate it. So here you've got to use a chain rule. So imagine you are differentiating this inverse sine of the bubble here. So you would then jump to this thing here. You would then jump to this thing here. Whenever you want to differentiate inverse sine of whatever here, just use this straight away. So that would then give you this. Okay, so we're starting out with this here, but visualize it as this being a bubble here. So when you differentiate this, it will then give you this. Remember, you've got to square this thing here. You've got to square the bubble here. You've got to square it. That's why you've got this squared here. Okay, and then you've got to multiply it with the differential of the bubble itself. That's this thing here. And then so here you've got this multiplying a fraction, so it gets multiplied to the top. That will then give you this. Okay, but bear in mind that because you've got the inverse sign here, I'm repeating myself here, because you've got this this thing here, you've got to take the domain into account. Beyond the domain, it doesn't really make sense. Well, anyway, dy by dx here gives you this here. Okay, so when you get a graph plot and plot this, it will give you this. Now remember, you got to take the domain into account. So when you take the domain into account, you've got to discard all of these here. You've got to discard here, discard everything over here. So looking at this here, this red line here was our original graph, y equals blah blah. When you differentiate it, it will be 1. So here it does make sense. It does make sense. If you don't take the domain into account, you will get something like this. Yeah, just remember to take the domain into account because of this thing here. Hang on, because the inverse sign here, the domain of inverse is between -1 and 1. You've got to take it into account. If you don't take the domain into account, something weird will happen. It will go beyond your control. Okay.